Revolutionary hydropower, unlocking unlimited clean energy potential. Hydropower, which is also called hydroelectric power, uses the force of water in motion to make electricity. People have been getting energy from water for a long time. In the 4th century BC, water wheels were already being used to water fields, and water mills were being used to grind grain. During the Industrial Revolution in Great Britain, when it was used to power new inventions, it was at its most successful. In particular, James B. Francis made the Francis turbine at the end of the 19th century. It's a very effective hydraulic turbine that can turn the potential energy of water into rotational energy that can be applied to a shaft. In renewable hydropower plants, the Francis turbine is the one that is the most used. But before we get too far ahead, we shouldn't mix up hydropower with tidal power, which uses the way tides move water in the ocean, or wave power, which uses the way ocean waves move to get energy. The value of hydropower digitalization. The generation of a vast amount of digitalized data at all stages of an energy supply chain is extremely important for the optimal control and management of any power plant. In the hydropower sector, digitalization is becoming an integral element of all stages of development, from planning and designing to construction and operation. Digitalization is a key opportunity to improve the hydropower sector by capturing data value, improving production, and reducing unexpected behavior. Most of the current hydropower plants were designed decades ago, and many work in different conditions from those existing at the time they were designed. Furthermore, the large share of solar and wind intermittent generation has also yielded unstable behaviors in the electrical power system, putting at risk its stability. And so, collecting and processing real-world data to adjust the working conditions of hydropower turbines can provide advanced grid support services without compromising reliability and safety. A total 42 terawatt-hours could be added to present hydropower energy production by implementing hydropower digitalization, which is 1.3% of additional annual energy generation, leading to $5 billion in savings and a reduction of greenhouse gas emissions, which would be produced if other sources generated that energy. Digitalization will enable a drastically reduced response time of hydro units, especially those of reversible pump turbines. Also, it will allow the assessment of the economic impact of offering additional reserve flexibility. In the next section, 2 industrial case studies on digitalization are described. Harnessing hydroelectricity. To harness energy from flowing water, the water must be controlled. A large reservoir is created by damming a river to create an artificial lake or reservoir. Water is channeled through tunnels in the dam. The energy of water flowing through the dam's channels causes turbines to turn. The turbines make generators move. Generators are machines that produce electricity. Engineers control the amount of water left through the dam. The process used to control this flow of water is called the intake system. When a lot of energy is needed, most of the tunnels to the turbines are open, and millions of gallons of water flow through them. By closing some of the tunnels, engineers slow down the intake system when less energy is needed. During floods, the intake system is helped by a spillway. A spillway is a structure that lets water flow directly into the river or any other body of water below the dam, skipping all tunnels, turbines, and generators. The dam and the community stay safe because of the spillways. Most of the time, spillways, which look like long ramps, are dry and empty. From water currents to electric currents. Large, fast-flowing rivers produce the most hydroelectricity. The Columbia River, which forms part of the border between the U.S. states of Washington and Oregon, is a big river that produces massive amounts of hydroelectric energy. The Bonneville Dam, one of many dams on the Columbia River, has 20 turbines and generates more than 1,000,000 watts of power every year. That's enough energy to power hundreds of thousands of homes and businesses. Water crashing over the fall line is full of energy. Hydroelectric power plants near waterfalls can create huge amounts of energy too. A famous example is the Niagara Falls hydroelectric plant, which spans the border between the United States and Canada. Hydroelectric energy generated by Niagara Falls is split between the United States state of New York and the Canadian province of Ontario. Engineers at Niagara Falls cannot turn the falls off, but they can severely limit the intake and control the amount of water rushing over the falls. Probably one of the largest hydroelectric power plants in the world is the enormous Three Gorges Dam, which goes over the Yangtze River in China. It is 185 meters tall and 115 meters thick at its base. It has 32 turbines and is able to generate more than 2 billion watts of power. The hydroclone digital twin technology. The hydroclone is an innovative real-time simulation monitoring system by Power Vision Engineering. It's a numerical copy of a hydropower plant that is able to reproduce in real time any dynamic behavior of the installation based on boundary conditions measured in situ. Hydroclone diagnoses the plant's health through numerical cloning of the major hydraulic and electrical components. The system handles the tasks of real-time acquisition and transfer of the measured boundary conditions and quantities to the model, data processing, and diagnoses of the power plant health. A tailor-made archival storage and related database system enables the display and analysis of previous results. The analysis and comparison of simulated and measured quantities enable the system to understand at any time the health state and behavior of all essential components of the plant, and to estimate non-measured or non-measurable quantities throughout the whole system. The hydroclone system has been implemented and tested since 2014 at the 200 MW La Batias power plant and has been operating continuously for over 5 years. Hydroelectric energy and the environment. A renewable source of energy will not run out. Renewable energy basically comes from natural sources like wind, sunlight, rain, tides, and geothermal energy, the heat produced inside Earth. Non-renewable energy sources include coal, oil, and natural gas. Hydroelectricity relies on water, which is a clean, renewable energy source. Water is renewable because the water cycle is continually recycling itself. Water evaporates, forms clouds, and then rains down on Earth, starting the cycle again. Reservoirs created by dams can provide a large, safe recreational space for a community. Boaters and water skiers can enjoy the lake. Many reservoirs are also stocked with fish. The area around a reservoir is often a protected natural space, allowing campers and hikers to enjoy the natural environment. Using water as a source of energy is generally a safe environmental choice. It's not perfect, though. Hydroelectric power plants require a dam and a reservoir. These artificial structures may be obstacles for fish trying to swim upstream. Some dams, including the Bonneville Dam, have installed fish ladders to help fish migrate. Fish ladders are a series of wide steps built on the side of the river and dam. The ladder allows fish to slowly swim upstream instead of being totally blocked by the dam. Dams flood riverbanks, destroying wetland habitats for thousands of organisms. Aquatic birds, such as cranes and ducks, are often at risk, as well as plants that depend on the marshy habitat of a riverbank. Operating the power plant may also raise the water temperature in the reservoir. Plants and animals near the dam have to adjust to this change or migrate elsewhere. Step into the future. The hydropower industry worldwide, especially in Europe, is currently in a phase of digitalization driven by new possibilities opened by a cheaper data collection and storage solution, cheaper sensory technology, and new solutions for data analysis. Also, hydropower digitalization is a sector in rapid development, well supported by the Internet of Things and Industry 4.0. The increase of energy generation by about 1.3% that was estimated to occur due to the implementation of hydropower digitalization is in line with the case studies discussed here. It should stimulate future development in this sense. What are your thoughts on this? Let us know in the comments section below. If you enjoyed today's video and found it interesting, then make sure to leave us a thumbs up. And don't forget to subscribe to our channel and click on the bell icon to always be updated with the most exciting content as soon as it's uploaded. Thanks for watching. See you soon in another video.